You're welcome, my dear student, in this new episode from your program مدرسة على الهواء to explain curriculum of science for Prep 1. Last time we talked about the atomic structure, and today we're gonna complete explaining the electronic configuration, and then if there is a time we can talk about energy. Electronic configuration. But first, we talked last time about the rule 2n square that control the number of electrons that fill the energy levels of atom. But today, on the monitor please, we can notice that the outermost energy level of any atom can't carry more than 8 electrons. Outermost means the last one, maybe the first if it has just one energy level as hydrogen, if the second, if the third, maybe a fourth, maybe fifth, maybe sixth, maybe seventh one. If it is the outermost energy level, the last energy level in this atom, it can't carry more than 8. Even if it can carry 32, even it is the third one that can carry what? 18. But if the third one is the outermost energy level, it can't carry more than 8 electrons. Okay, so now the question is make electronic configuration for number 1 sodium Na, 2 calcium Ca, 3 argon Ar. Sodium Na. Sodium Na is written like this: 1123. First, what's meant by Na? It is the symbol of sodium that consists of 2 letters. First one is capital and the second is small. It comes from natrium, the Latin word that means sodium. What's meant by 11? It is the atomic number. That means number of protons or number of electrons in the atom. What's meant by 23? It is the mass number. That means number of protons plus number of neutrons. But here number of protons only. So first, if I ask you to find out the number of neutrons. Number of neutrons here equal mass number minus atomic number. That means 23 minus 11, and it will be what? 12. So this atom, the atom of sodium, contains 11 protons, 11 electrons, and 12 neutrons. Now he asks me to make the electronic configuration, so I must first make the diagram by making first the nucleus and write here 11 protons and 12 neutrons. Then first energy level, second, third. First one, K, is saturated by 2 electrons, so I write 2. It can carry 2 and saturated by 2, and I have 11 protons. Now 11 minus 2, the remain is 9. Can I put 9 here in L? No. Why? Because L now is the outermost energy level, and if it is the outermost energy level, it can't carry more than 8, so it is wrong. I must write 8, only 8. Why? Because the outermost energy level can't carry more than 8. Then now the remain is 1, just 1 here. This is electronic configuration for sodium. Number 2, calcium. Calcium 20, 40. What's meant by 20? 20 means the number of protons. 40, number of protons plus number of neutrons. So 20 and here 40. K, L, M, N. K saturated by 2, L saturated by 8. Now I have 10. Why 8 here? Because now it is the outermost energy level. But now there are 10. Can I put 10 here? No, it's false, it's wrong. Because it will be the outermost energy level that can't carry more than, yes, more than 8. So I must put 8 and the remain what? 2. So it will be 2, 8, 8, 2. Okay. Argon. Argon gas. AR what? AR 18. So here 18 positive. First one K, L, M, N, O. K can carry what? Yes, 2. L can carry 8. Now they are 10. So the remain is 8. Yes, 8. Notice this atom is saturated. The outermost energy level contains 8. So it is saturated. It's called noble gas because its outermost energy level is filled completely with the 8 electrons. On the monitor, please. This is argon, 2 and 8, then 8. This is calcium, 2, 8, 8, 2. Oxygen, 2, 6. Helium, it contains only one energy level that is saturated by 2 electrons. It's filled completely. So it is called an inert or noble gas. And this is fluorine. Fluorine has 9 electrons and its configuration is 2 in K and what, and 7 in L. Now, my dear student, let's talk about Unit 2, Lesson 1, Energy, Resources and Forms. We talked about energy before, and every one of us knows that energy is the ability to do work. But now the question is, if I wanted to do work, if I wanted to move this stage, and I tried to move this stage, but it didn't move. The question is, does or did I do work? No. Work here means 0, equal 0. Why? Because work, I didn't do change. I didn't do any change. So work equals 0. Work means 2 factors. Number 1, the force, the weight that I can carry, the weight that I can move, times displacement. Displacement means the distance in a straight line that I moved this weight. Suppose that I have a bag. This bag, the mass of this bag is 10 kilogram. Okay, and its mass, but weight equal 10 times 10, mass times 10, as we studied in primary 6. So its weight is 100 Newton. 100 Newton. I tried to carry this force 100 Newton for 1 meter. Now I exerted work. If I wanted to carry it for 2 meters, the work is doubled. But if I couldn't move it, so I didn't do work. So first, as you see on the monitor, we have 2 different examples. First one, the person who tried to move the wall, he can't. So work done equals 0 because it didn't do change. But the second one is the man who tried to move this wheel. If the wheel moved, it means that he did work, that he exerted work. So now work equal force times displacement. But notice, my dear student, that work in joule, force, its unit is Newton, and displacement is measured in meter unit. Notice, displacement mustn't be in kilometer, mustn't be in centimeter. If you find it in the exam in centimeter, you must convert it into meter. If you find it in kilometer, you mustn't change it or convert it into meter, because displacement must be in meter, force must be in Newton, and work must be in joule. Okay, by increasing force, work increases. By increasing displacement, work also increases. Suppose that I try to carry a bag, its mass is 5 kilogram. 5 kilogram. To move it 1 meter. Oh, I exerted work. If another time I carry 10 kilogram to move it 1 meter, the work is doubled. If I try to carry 15 kilogram to move 1 meter, the work is treble. So by increasing force, by increasing weight that I can carry, work increases. And displacement. Suppose if I have a bag, its mass is 5 kilogram, and try to move it for 1 meter, I exerted work. But if I carried 5 kilogram for 2 meters, the work is doubled. For 3 meters, the work is tripled. So by increasing displacement, work increases. Okay. What's meant by energy? Energy, as I said before, it is the ability to do work. But what are the sources of energy? First one is the sun. And the sun is permanent. Permanent resource means the source that doesn't vanish, that live forever, not vanish, not finish, but it continue forever. Number 2, wind. Number 3, fuel. Number 4, food. The sun is a resource of energy because it gives us energy, it gives us heat and light. Wind, we can use wind to have kinetic energy, to generate electricity. Fuel, we can use fuel to move our cars, move planes, move trains. We can use fuel to generate electricity. Food, we use food to generate heat and the kinetic energy inside our bodies. So resources of energy, number 1, sun, wind, fuel, food, and another 2. We have many resources of energy. We have nuclear energy. We have nuclear energy. Another one, we have nuclear energy from nuclear reactors. But now let's talk about the forms of energy. Forms of energy. We have many forms of energy that we studied before. As we see on the monitor, this is number 5, movement of water and nuclear reactions. But now let's talk about the forms of energy. Number 1, light energy as electric lamps, light energy as the sunlight, as you see. Number 2, sound energy as loudspeaker. Number 3 is electric energy as wind generator. Electric energy, that wind generator that generates electricity, electric generator. So it's electric generator, not wind generator. Number 4, chemical energy as food. Food contains chemical energy that changes inside our bodies to kinetic and heat. Number B, car battery that has chemical energy that it changes into electric energy. Number C, fuels that contains also chemical energy. Heat energy as heater all types of heater. Number 6, nuclear energy as energy produced from the reactions in the nucleus of the atom. Mechanical energy. Mechanical energy here means potential and kinetic energy. Potential and kinetic energy. So what's meant by mechanical energy? Mechanical energy, it is the summation of what? Of potential and kinetic. Potential plus kinetic energy, it is called what? Mechanical energy. So first we have to talk now about potential and kinetic energy. First, what's meant by potential energy? Potential energy means that everybody is constant, doesn't move, has energy. It's called potential energy. It is the energy of body due to its position. It's energy stored inside the body due to its position. It's potential energy, as you see on the monitor. This stone is on the mountain. It has height, so it has potential energy. It is stored energy in the object due to the work done on it. We have two types of stored energies, my dear student. Number 1 is potential energy. It is stored. I can't see, I can't feel, I can't smell, it's just stored energy. And chemical energy, that is stored in fuel, in battery, and in food. But potential energy is affected by height and weight. Suppose that I have 10 kilograms, my dear student, and I carry it on my hand in this position for 1 minute. Oh, it's heavy. But if I want to carry this 10 kilogram on this position, oh, I will be more tired. Why? Because I exerted more energy, because potential energy is increased by increasing height. By increasing height, potential energy increases. And weight. If I carry this 10 kilogram in this position, and another time and carry 20 kilogram in the same position, which time I exert more energy? Yes, second time. Give reason. Because by increasing weight of object, that is affected by mass, by increasing weight of object, the potential energy increases. So potential energy is affected by two factors. Number 1 is height of the object. Number 2 is weight of the object. So potential energy equal, as you see, height times weight. H is the symbol of height, W is the symbol of weight, P dot E, P capital dot E capital, the symbol of potential energy. So potential energy equal height times weight. Potential energy is measured by joule. Height, it's measured in meter. Weight is measured in what? In Newton. Factors affecting the potential energy. Number 1, height. By increasing the height of object from the ground, its potential energy increases. Number 2, weight. But now, how can I get weight? Weight equal mass times acceleration due gravity. Acceleration due to gravity. Acceleration due to gravity is symbolized by G small. Mass is symbolized by M. So weight equal mg, mass times acceleration due to gravity. Acceleration due to gravity is supposed to be 10 meter per second square. It's constant. It's 9.8, but if you didn't find it in the exam, you can say that it equals 10 meter per second square. It is G, acceleration due to the gravity. And mass must be in kilogram. Weight must be in Newton. Notes again on the monitor, please. Weight in Newton. Mass must be in kilogram. Mass here must be in kilogram, not in gram. If you find it in gram, you must convert it into kilogram. Okay. Second, let's talk about kinetic energy. What's meant by kinetic energy? It is the energy, or it is the work done during the motion of an object. Work done during the motion of an object, or it is energy of object due to its motion. The same. The moving car, as you see, has energy. It's called kinetic energy. Any moving object has kinetic energy. If you move, you have kinetic energy. If you stop, you have potential energy. But the summation of potential and the kinetic are called together, are called mechanical energy. Factors affecting kinetic energy. Number one, mass. Mass of object. By increasing the mass of object, its kinetic energy increases. Let me give you an example, my dear student. If I have a small car and another very big car, and the two cars move with the same speed, which one has more energy? Which one can stop easily? Sure, the smallest car stopped faster than the bigger car, because its energy is smaller than the bigger car. But the bigger car can't stop easily, because its kinetic energy is higher, is bigger, is more. By increasing mass of object, its kinetic energy increasing. Number two, speed. If I have two cars have the same volume, the same size, and move together, first one moves at 60 km per hour and second moves with 180 km per hour, which one, if the driver wants to stop, which one stops easily, which one stops fast? First or second? Yes, first. Because by decreasing speed, you can stop your car easily, because its kinetic energy is not big, it's a small kinetic energy. But the car that moves with higher speed, it has more kinetic energy. So the factors are two. Number one, mass. By increasing mass of object, its kinetic energy increases. Number two, speed or velocity. Speed here means velocity. Velocity is speed but has direction. Its velocity increases. Okay, by increasing the velocity, its kinetic energy increases. On the monitor, please, factors affecting kinetic energy. Mass of object. By increasing mass of object, its kinetic energy increases. Number two, velocity of the object. By increasing the velocity, the kinetic energy increases. So, kinetic energy equal mass half mass velocity square. Half mass velocity square. Okay? Half times mass, but mass half mass velocity square. Mass here in kilogram, velocity in meter per second square. Kinetic energy. Now let's go to the this question. It's not easy. An object whose mass is 8 kilogram. Mass equal 8 kilogram. It's in kilogram. Yes, it's okay. It's good. Was thrown up until it reached its maximum height. This is the object. Its maximum height at 15 meters. Above the ground. Above the ground. Its velocity, find its velocity. Now he needs what? He needs velocity at 3.75 meter height. Now he gave me mass, and already I have gravity acceleration. It's constant, 10 meter per second square, and we have height 15. How can I get mass? I can't get mass even I have kinetic energy that equal half mass velocity square, but I don't have kinetic energy. How can I get kinetic energy first? Kinetic energy plus potential energy equal what? Mechanical energy. Mechanical energy, any position equal mechanical at any position, and potential energy at the top equal kinetic energy before reaching the ground. So mechanical energy equal potential at the top. So if I got potential at the top, I can get mechanical energy. So potential energy equal mgh. M here is 8 times 10 times 15. Okay, it will be 1200 watt joule. Okay, this is mechanical energy equal 1200. But potential energy at 3.75 meter will be, if you wanted to write mgh, it will be what? It will be 300 joule. So kinetic energy here equal what? Equal 1200, it's mechanical, minus potential 300, so it will be what? It will be 900. Okay, so kinetic energy equal half mass velocity square, so velocity square equal kinetic energy divided half mass, so velocity equal root square of kinetic energy divided half mass. And I have now kinetic energy and I have mass, so I can easily get velocity. Now the time is out, so I have to say goodbye. But before saying goodbye, I have to say wait for us, because after me, directly with Miss Rasha, we will study science curriculum for second prep. Thank you and goodbye.